In this video, we are continuing our Investigating Life series. In the previous episode, we talked about Mercury and estimated its probability of hosting life to be roughly zero, so a negligible probability that life could be sustained there, and that was because primarily the extremely hot and extremely cold temperature variability makes it impossible for life as we understand it to adapt. And therefore it would not be able to sustain itself. We started off the entire series with defining life and going through the origins of life and kind of breaking down how life evolved on Earth. But the subject of this video is Venus, and the prospects are actually much, much greater that life exists on this planet. And I was actually surprised when I was looking into this that is the case, and it's actually really quite exciting. Now, we can actually eliminate the surface layer of Venus as a place that will be friendly to life. It is way too hot at roughly 450 degrees Celsius, we estimate, and that its pressure is 90 times that of Earth. So that's equivalent to if you were able to dive 3,000 feet below sea level, which you cannot. So we can actually move 55 kilometers above the surface of Venus. And we call this the cloud layer. Scientists call this the cloud layer. And it is actually really hospitable to life. The temperature and pressure is very similar to the surface of Earth, which we know can sustain life. Its chemical composition is interesting. At the surface, it's almost 95% carbon dioxide. And at that temperature and pressure, carbon dioxide acts or functions as a supercritical fluid. And so the barrier between gas and liquid sort of breaks down, and so it's kind of functioning as both at that surface, which is really cool to look at and think about. And we've even sent probes there in the 70s, and we've generated images of what it looks like. And there's a lot of volcanic activity, which is important for our analysis of possible life, because it could be shooting nutrients into the atmosphere that sustains life, allows their metabolism to function. It gives them energy and food, which they could use to sustain themselves. The other interesting factor is the density, given the chemical composition of this cloud layer, is much different than our atmosphere, which is oxygen and nitrogen, very, very low density, which is why no living organism exists in the atmosphere. Everything requires energy to stay, so anything that flies requires energy and then eventually has to come down. But the prospects on Venus are different in the Venusian atmosphere because it's so much more dense. Larger structures could just permanently float there, which is important. The other aspect and feature of this cloud layer, which wraps around the entire planet, is that it is very windy, 100 meters per second, and this will make conditions very difficult for structures to take place that can survive that level of wind on a regular basis. So they sort of have to develop a mechanism to withstand that level of wind. So that lowers the probability. And remember, the focus of this video is to estimate a probability for life there and why it might be a good candidate to investigate over another candidate, such as Mercury or Mars or the moons of Jupiter and Saturn. So that is the objective here. And so we have in the upper atmosphere sulfuric acid, and then we think in the cloud layer we have a very strong oxidizing environment with sulfate, with water vapor, with carbon dioxide, carbon monoxide. But super interestingly, and there was a ton of debate around this, and you can do a whole video on the debates and battles between different scientists about the validity of these measurements, but there was a reading or a signature indicating phosphine in this cloud layer, and we are going to operate from the assumption and base level that it is phosphine that exists there, and that was pretty much corroborated. There's a much greater consensus that is the case after recent work in 2024, and it's troubling. it makes it difficult to understand why there's phosphine there, given such a strong oxidizing environment. So now a scientist put together a reaction that could take place to generate a product like phosphine, and it requires a lot of energy in that sort of environment. It's 8 protons are needed to react with phosphoric acid. And where are you getting these protons that should be reacting with oxygen in a reducing agent manner? So from an evolutionary perspective, it doesn't make sense to produce phosphine. So the mechanism that a biological organism is creating a metabolic byproduct in phosphine is unlikely, even though that's what we see here on Earth. Almost all the phosphine on Earth is produced from bacteria and archaea. But it doesn't make sense in the oxidizing environment because it happens here on Earth in anaerobic conditions. So that's extremely unlikely. The other possibility is that our model for and theory for the chemical environment is incomplete for the Venusian atmosphere and this cloud layer. It's certainly possible that there are certain mechanisms taking place that we just don't know about and that we don't see on Earth, and so we can't experimentally and predict what is going to happen with statistical significance. And so that puts our prospects lower than you would like, but we just need more data. And so there's a mission called the Veritas mission to go and sample part of this cloud layer in 2030, 2031, around there. And so we can get and see what's going on, what the atmosphere is actually made of. We might even be able to see if biological life is existing in this layer. And the other cool part is if it is existing there, so it's got to be an aerial phenomenon. It's going to be like in this cloud layer, which is like a fluid and it's floating there. And then as it grows and grows and grows, eventually it's going to keep sinking and move closer and closer to the surface of the planet where it heats up and denatures. And then as it consolidates, it's going to break down and evaporate and then move back up to the cloud layer. And this is like the life cycle you could imagine for this organism. So why don't we get into the numbers and say that we are estimating the probability for life to exist in this cloud layer to be around 10 to the negative 5. The penalties are 0 for temperature and pressure because it is almost identical to Earth. We have geological activity, so the volcanoes, that creates instability, believe it or not. So even though they may be providing nutrients, it could also be preventing a stable system from taking place. And so you could give that a penalty of 10 to the negative 1 or 10%. The biggest penalty comes to the chemical composition. We don't understand, and our measurements aren't adequate enough to really focus on or narrow down what is going on there. So we estimate that penalty to be around 10 to the negative 3. And so the last penalty experienced by any life form that would exist in here is the wind speeds, the necessity to withstand such violent wind and have the structural capacity to survive that while also floating aerially in this cloud. Again, it's okay that it can consolidate as it grows and then die as it moves closer to the atmosphere. That's fine. Create its life cycle where it moves back up and evaporates back into the atmosphere. But there has to be a penalty there, and we estimate that to be 10 to the negative 1. So overall, we estimate the probability of life existing in this cloud layer to be 10 to the negative 5, which is in stark contrast to our probability estimation for Mercury, which we put, I think, around 10 to the negative 24, which is basically 0. And so if I was starting a mission, you would go to Venus over Mercury. And then we can compare that, run a comparison data table or chart, and see how Venus stacks up against the other planets and moons in our solar system. And then we can even think about other solar systems nearby. I don't want to look too far because there's no way we'll ever go there. And so that is where we'll end this video, and we'll see you in the next one, which will be Mars.